Can you really tell the difference between all the ways your body proves who you are? You know your fingerprint unlocks your phone, your face gets you through an airport gate, and your iris can open a secure vault. But do you actually understand how these systems know it's really you? And more importantly, could someone else trick them? What happens if the physical traits that make you unique, your fingerprint, your face, or your eyes, could be copied, faked, or stolen? In today's world where digital identity theft is becoming more sophisticated, understanding how your body becomes your password is no longer optional. It's essential. This video will help you uncover exactly how physiological biometrics work. The science behind the physical traits that make every human one of a kind. Welcome to this lesson. Physiological Biometrics Explained. By the end of this video, you'll understand what physiological biometrics are and how they work. You'll also explore key systems such as fingerprint, iris, retina, face, hand geometry, and DNA recognition, along with how they're applied, what advantages they offer, and where their limitations and risks lie. Stick around till the end, because we'll also reveal how these physical traits shape modern security systems, from your smartphone to border control, and why even the strongest biometric systems can still be vulnerable. Physiological biometrics are technologies that recognize and verify individuals based on their physical and biological characteristics, traits that are naturally part of their body and remain largely stable over a lifetime. These characteristics include fingerprints, facial features, iris and retina patterns, hand geometry, and even your DNA. They are like nature's permanent password, always with you, impossible to forget, and incredibly hard to replicate. But to truly appreciate their power, we need to understand how each type functions in practice and why each has its own strengths and weaknesses. A fingerprint is often described as a person's natural barcode, composed of ridges, valleys, and intricate patterns that remain unchanged throughout life. When you place your finger on a scanner, the device captures an image of your fingertip and extracts key features known as minutia points, those tiny details where ridges end or split. These unique points are then transformed into a mathematical template, which is compared against stored data to verify your identity. Because of this precision, fingerprint systems are widely used in smartphones, attendance systems, border control, and ATMs. They are valued for their accuracy, speed, and affordability, making them one of the most common forms of biometric authentication. However, their reliability can be affected by real-world factors. Dirt, scars, or moisture on the finger can cause recognition failures, and people with worn fingerprints may experience reduced accuracy. There's also the challenge of spoofing. Attackers can sometimes create fake fingerprints using silicone or printed molds. Modern systems counter this with anti-spoofing detection, ensuring fake prints are rejected before access is granted. Moving upward, the iris, the colored ring around your pupil, contains a network of furrows and crypts so intricate that even identical twins have different patterns. An infrared camera captures this iris texture, and specialized algorithms extract these details, encoding them into a digital template. This method offers incredible accuracy because the iris remains unchanged throughout life and is difficult to forge. It's also contactless and hygienic, which makes it suitable for high-security uses. Iris recognition powers systems like Identification Card Project and airport e-gates. But with these strengths come challenges. The system requires high-quality cameras and good lighting. People wearing glasses or contact lenses may experience interference, and the cost of deployment is significantly higher than simpler biometrics. Moreover, unauthorized capture of someone's iris image raises privacy concerns, especially when it's done covertly through cameras or surveillance systems. Retina recognition dives even deeper, literally. The retina, located at the back of the eye, contains a network of blood vessels that form a pattern even more unique than fingerprints. A low-intensity infrared beam scans this network, capturing a detailed image that serves as an ultra-secure identifier. The strength of this method lies in its extraordinary accuracy and permanence. It's virtually impossible to duplicate a retina pattern, which is why it's used in military installations, nuclear power plants, and high-security research facilities. However, it comes with significant drawbacks. Users must align their eye precisely with the scanner, which many find intrusive. The equipment is expensive and not suited for mass use, and certain eye conditions can interfere with results. Despite these challenges, retina recognition remains the gold standard for environments demanding absolute identity assurance. Facial recognition analyzes the geometry of your face. The distances between key landmarks such as your eyes, nose, mouth, and jawline. The system captures a 2D or 3D image, extracts these landmarks, and converts them into a numerical vector that uniquely represents your face. Its biggest advantage lies in convenience and non-intrusiveness. You don't need to touch a device. A simple glance can unlock your phone or pass you through an airport gate. This makes it ideal for surveillance, quick verification, and user-friendly authentication. But the same convenience introduces risks. Lighting changes, camera angles, or facial expressions can affect accuracy. More importantly, studies have shown that some systems perform inconsistently across different skin tones or facial structures, raising concerns about bias and fairness. There's also the growing threat of spoofing using high-quality photos or deepfake videos, which makes robust liveness detection crucial. Hand geometry focuses on the physical dimensions of your hand, measuring the shape, thickness, and proportions of fingers and palm. While not as unique as fingerprints or irises, it's reliable for quick verification where medium-level security is sufficient. Its strength lies in simplicity and ease of use. Users simply place their hand on a scanner, and the system measures and compares the shape against stored profiles. It's used in workplaces, factories, and time attendance systems because it's fast and intuitive. However, hand geometry is less distinctive, which increases the risk of false matches among individuals with similar hand shapes. Devices can also be bulky and raise hygiene concerns when shared. These factors make hand geometry better suited for controlled environments rather than personal devices. Finally, DNA recognition, the ultimate biological identifier. Every cell in your body carries the same DNA sequence, which is nearly impossible to duplicate or fake. DNA recognition works by collecting a biological sample such as blood, saliva, or hair. Scientists then analyze genetic markers using a process known as polymerase chain reaction, PCR, to create a unique DNA profile, which is compared with existing records. DNA recognition can identify individuals with near-perfect certainty and is invaluable in criminal investigations, disaster victim identification, and paternity testing. However, it is time-consuming, costly, and requires specialized lab equipment, making it impractical for everyday use. Ethical and privacy issues also loom large, as genetic data can reveal sensitive health or hereditary information. The potential misuse of this data or unauthorized storage of genetic profiles presents a serious concern in data protection law. In summary, physiological biometrics rely on your body's physical characteristics. The fingerprint patterns on your hands, the structure of your face, the colors in your eyes, the geometry of your hand, and even the code written in your DNA. They deliver powerful authentication because they're stable, personal, and difficult to forge. Yet, these same traits come with serious considerations, from privacy invasion and spoofing to ethical debates over data ownership. Understanding these systems helps us strike the right balance between security, convenience, and human rights. In our next video, we'll shift from the physical to the behavioral, exploring how your actions can identify you just as uniquely as your body does. From your voice to your typing rhythm and walking style, we'll see how behavior becomes your digital signature. If you found this lesson insightful, don't forget to like, share, and subscribe, and turn on notifications so you don't miss the next episode lesson.